Hello, everybody. My name is Jody Axelson, and as you can see from the title slide, I am the research leader in silviculture at Resource Practices Branch. I'm pleased to be here virtually recording this talk for you on behalf of Suzanne and I, where we sort of explore some of the threats to healthy forests, healthy young forests, kind of consider the surprises and the things that shouldn't be surprising, actually, as we move forward and think about reforestation in times of uncertainty. Before I really can think about young stand health, I like to think of health more broadly. You know, what is a healthy forest, in fact? And this definition from a special issue of Forest Health and Global Change, which is really excellent, is one of the many definitions out there. And what strikes me about this definition is they specifically talk about that there is a mosaic of successional patches on the landscape, which represent the different stages and ranges of disturbances and recovery, right? And I think this is a really important point. And this schematic to the left is sort of showing out of any given forest area undergoing any kind of tree stress or forest disturbance, you have these sort of three basic states of healthy, where the background processes that are operating in the stand aren't exerting so much stress that it is changing the form or function of a stand. Somewhere in between, where things maybe become unstable, and processes, functions, etc., are destabilized, and the system becomes maybe unhealthy. And then this red zone of where a stand is unhealthy. And I would argue that people who work in the disturbance world are really interested in this dash line. How can we determine the thresholds? Do they exist? Can we quantify them? Of where where you push the forest, you push it too far the other way, right? Just because you lift the straw off the camel's back doesn't mean the camel's back is unbroken. And so often these changes in state can be permanent or certainly not easy to reverse. This other definition of forest health I also like, and from a number of folks, including retired Renelle Farrow, where they consider a healthy forest one in which the underlying ecological processes are intact across any temporal and spatial scale. There's sort of resilience to the historical disturbance regimes. And so this is actually a fairly short definition with a lot to unpack. I don't think we can think of forest health or forest at all without considering time scales or the spatial scales at which we're talking about. Scale is really important. And as we face ever increasing changing climate and more extreme events and changes to disturbances, are our forests evolving? Are they experiencing disturbance regimes with which they have evolved? Are they experiencing novel changes? So I'm going to briefly cover off some threats, many threats not included in this, but some of the more pressing threats, and I think that are salient in the last number of years in Western North America broadly, but also in British Columbia specifically. So these are a number of maps I'm showing from Climate BC, and on each, there'll be a number of these, and on each one, on the left-hand side will be mean annual temperatures, and on the right, mean annual precipitation. And so this is our climate past, actually, 1961 through 1990, referred to as a climate normal period. And we see the sort of range of temperatures and range of average precipitation across the landscape. So the coast is warm and wet. The interior is cool and dry. Not that surprising. This is more or less the world we live in. Here's a climate change future with the same areas projected to 2050. And so it might look like the maps haven't changed, but the scales have changed, and that's important. So we've seen a 3-degree increase in temperature across the board in this projection. And we see a change also in precipitation. So higher levels of precipitation than in the climate normal period. And precipitation isn't really well handled still by the climate models for a myriad of reasons. But what it looks to me like is we see increasing wetness on the coast and increasing dryness in the interior. And of course, we understand there's a lot of variability in that system. Now, this is climate change, we could say now. So from 2001 to 2009, we see again on the left-hand side the changes in temperature, right? So very low changes in temperature, only 0.01 around the coast, and then very high changes in temperature up in the northeast of almost 2 degrees. And then this precipitation graph is showing us a little better sort of this range of outcomes for precipitation, where there might be quite a significant increase in temperature in our northwest region, or moderate changes throughout the central interior, and then areas where it gets quite a bit drier. So climate change is a reality. It's happening now, and arguably represents some of the biggest threats to forest health. For folks that were at the research meeting that the provincial research group has every 2 years, different groups were tasked with doing an infographic. And so this was the Waters Group's take on drought. Drought is a natural phenomenon, right? But drought does threaten our values, and those are sort of shown here. And drought threatens our forests. And what we know, what the climate models do not quibble about, is temperature is increasing. And how much temperature increases really depends on the scenarios used and how much our emissions increase. Precipitation, again, as I said, is a lot more variable. But what will happen, no doubt, because we already experienced droughts, is those droughts are now going to be hotter, which will put even more strain on forest systems. Of course, we also have wildfires. Now, this graph is interesting. On the left-hand axis, we see the area burned in hectares from 1990 to 2019, and those are the orange bars. And on the right-hand axis, the number of fires over that same period. And so, with, of course, you would expect a lot of variability in the number of fires from any year to year, but the trend is pretty clear that there's a decreasing trend of number of fires. And we tend to be very good at fire suppression in North America. What is really apparent, especially in the 2017-18 years, is how much of an increase there has been in area burned. And this really gets to the heart of some of the matters around reforestation. What do we do with these massive wildfires? We have these really large areas burned. And that is unlikely to change as we experience hotter temperatures, more frequent droughts, and the like. This very simple graphic, I think, summarizes a lot of the, it certainly summarizes the way I think about disturbance feedbacks. And so you have climate, which is affecting the frequency and severity of disturbances, affecting insects and pathogens, which often are heavily influenced or directly controlled via climate, and also physical disturbances, say drought or wind throw, these extreme events. We have tree distribution and tree physiology that play a role here, which climate to some extent influences, and which certainly influences the disturbances, and then this forest composition, structure, and function. The only arrow I think they missed is that forest composition, structure, and function can very much influence the insects and pathogens which disturb stands. And I'll get more to that later. This was a really interesting paper fairly recently by Seidel and others, where they did a really massive literature review of the evidence for direct, indirect, or interactive effects of climate change on forest disturbances. And so for every agent in this schematic, the arrow width and percentages indicate the relative prominence of the respective effect as expressed by the numbers of observations that they extracted, right? And so for fire, for example, we see this very strong, thick arrow. 63% of fires can be attributed to the direct effect of climate change, right? And then we have the indirect effects here on the top, and minimal interactive effects. If we go to the other side of this graph, or this schematic for insects, we see climate but more interactive effects are really driving changes in disturbances. And so this is quite interesting way to look at it and to summarize a large amount of literature about what we know. Interestingly, for pathogens, there was a very strong direct effect of climate on pathogens. And then at some point you get this enhanced mortality, right? It could be for abiotic or biotic disturbances, but you have this sort of death spiral. And this is really by myself and my co-authors in California, a reimagining of sort of Mannion's spiral, but where disturbances are sort of nested in one another. They don't need to be sequential, they're not sequential, and they're not even necessarily cumulative. They could be, but they're not necessarily so. But as a tree's health declines, and for whatever reason that might be, it's going to take weaker and weaker disturbance agents to potentially result in its death. I would argue that up in this area, a tree can be experiencing decreased vigor, but at some point could kind of pull out of the spiral. But somewhere down in here, it's sort of a foregone conclusion. You know, you've had maybe drought, unsuccessful bark beetle attack, maybe root rot, and then finally a wood borer comes along, or a set of wood borers come along and finally do the tree off, right? And these different disturbance agents could be modified to the system at hand. This was done in this schematic was done up with Californian disturbances in mind. So I've sort of characterized healthy forests, some of the threats from extreme events and climate change, and sort of ways to think about how climate interacts with disturbance agents to increase tree stress and death. And so let's get to more of the meat of the topic, which is the health of young stands. And I want to start with natural regeneration. So the role of legacies in regeneration. The post-disturbance regeneration forest is really subject to multiple complex and interacting variables. What was the type of disturbance, first of all? How severe was that disturbance? What residual overstory structure and composition is there? Is there a seed source or is there not? Understory structure and composition. Whether there is a selective mortality that occurs, and so you get a release of advanced regeneration, which sort of quickens along your recovery, the rate of seedling establishment or vegetative sprouting, you know, especially in areas where you get strong sprouting of heavily competitive shrub species. Again, California is a good example of this. In a summer drought-driven climate, some of these shrubs can really exert a lot of moisture stress. And then there's regeneration of shrubs, forbs, and herbaceous layers, grasses, etc. So all of these things can impact what kind of regeneration you might expect after a disturbance. I want to give you an example from some of my work I did when I was at CFS with Renee Alfaro and others, where we revisited a set of stands in Waterton Lakes National Park in Alberta, and basically through happenstance, we're able to develop this 30-year chronosequence of 30 years after the bark beetle. And so within a very small area in the park, in all lodgepole pine leading stands, we have very variable mortality from this mountain pine beetle outbreak, right? We see the percentage of trees that are live in this graphic. So stand 1 experienced almost no mortality whatsoever, whereas stand 4, which was across the road, interestingly, almost is entirely killed by the mountain pine beetle. So you can look at that sort of overstory story, and you can also look at the understory to say, okay, so in 2002, when they went back to remeasure it the first time, and then in 2010, where we went back again to remeasure it, what are we seeing for density of natural regeneration in these sites? So again, we have stands on the x-axis, and we have saplings in this top panel, and then small regeneration on the bottom, and then these 2 timestamps. What's clear to me is that succession is operating in many of the ways you would expect, and that there is still a forest there. And so in some way, there's resilience there as well. What also jumps out at me is there is no pine, right? So if you are managing, if you're banking on there being pine in the system for a future harvest, then this isn't a very resilient system to you. But succession is carrying on, and we're seeing this sort of quite complex stands made up of many, many species, sort of depending on the site. Stand 2 was one of the more xeric. So we see lots of Douglas fir coming in this site. Stand 5 was more mesic, almost riparian, and you see a lot of balsam poplar. And so it shows that this disturbance sort of doesn't lay waste to the stand, and that there's this whole generation of new trees that are surviving, growing, and in many cases thriving in this stand, but not necessarily the species we might want. Because fire is only going to become a larger part of our disturbance story, I thought this was a really interesting study by Christian Shive and others from Berkeley. So this is the King Fire, which burned in the fall of 2014 and covers an area of about 395 square kilometers. And so really what they, what this fire does is 46% of it burns at very high severity, right? And so the central patch, which is this sort of brownish tan area, covers 10,000 hectares, sorry. And so they did a number of field-based methods and predictive methods to look at what was the probability of observing at least one single regenerating conifer within any 60 square meter area. And as you would expect, the probability is extremely low in this central patch, right? And this makes sense. Remember your Silvix. There's no, seeds only move so far. So the distance to edge is really, really far, and it's very unlikely that there is going to actually be any natural conifer regeneration within that really large area of that high severe fire. What's, I think, useful about this study, so that's not groundbreaking, this is sort of what we expect, is in this brown, this sort of dark blue area or green area, these sort of predictive surfaces and maps give us an idea of where we need to focus. Where do we need to pay attention? There's a reasonably good probability that there's going to be good regeneration. That's actually very good probability there'll be regeneration on these edges. So let's leave those alone. Let's focus on these interiors, especially these brown areas where there is very low probabilities if we want to be thinking about reforestation in these areas. And given our wildfire seasons of 2017-18, we don't have the choice any longer to not think about how these large wildfires become reforested. This is another study. This is out of the US Rocky Mountains, and they took 52 fires that burned before the 2000s, before 2000 and after 2000, and looked at close to 1,500 sites. So a really rich data set. And what we see, so this is the recruitment threshold graph, and so they've simplified their system into dry and moist forests before 2000, and then dry and moist forests after 2000. And what we're seeing here is the proportion of sites that meet this recruitment threshold. So gray is, yes, it did meet the recruitment threshold, and black is, no, it did not. And so not unexpectedly, we see a high level of recruitment threshold being met in the moist forests and less in the dry. The same pattern holds after 2000, but we see less of overall a recruitment threshold being met. This is a very similar graph where gray means yes and black means no, and this is seedling presence. And again, this is seedling presence, a single seedling at any one site. So these are low numbers. And again, it's that same pattern that after 2000, we see less seedlings being present and we see less recruitment thresholds being met in both dry and moist type forests. And so the lack of regeneration leads to these substantially longer periods of forest recovery, right, to any kind of pre-fire density. And this is being driven by a warmer climate and drier mean conditions. And so there's this increased vulnerability in both these dry and these moist forests that are basically inducing regeneration failures. Now, if you're listening to this, you can be like, oh, Axelson, you know, you're talking about California and the Rocky Mountains. These areas are really dry. This doesn't really hold in BC. Given that temperatures are rising everywhere and droughts are becoming more severe, I would argue that that's not the case. But these are interesting studies that can kind of demonstrate these changes in resilience, these regeneration potentials or lack of potential. So let's turn our attention to reforestation, because really that's what this seminar series is about. And so I don't really think about reforestation without first thinking about a number of questions around that, which is, what is being planted? Where is it being planted? At what densities is it being planted? And at what proportions? Are we planting all one species, or are we planting mixes of species? Are the trees surviving? But I think more than just surviving, you know, are they thriving? Is there future possibility for, you know, these young forests to thrive? And was the original silvicultural system the right one to start out with? And I think that is an important question that we need to start to really look at, whether we like it or not. So reforestation practice. This was in a special investigation that came out this fall from the Forest Practices Board, specifically in the IDF. So is what we're doing working? Well, in the IDF, apparently it is not. In this case, the 60%, greater than 60% of the blocks had poor to marginal conditions. The reforestation was meeting only the minimum targets. There was an over-reliance on clear cutting, so that gets to the question of, are we even using the right silvicultural system to begin with? Best management practices were not ultimately being followed very well, and very concerningly, there was overall a lack of critical thinking on the long-term stand development. And I'm not reading between the lines of this report. This is pulled out of this report. So what do we plant? This is older data, but it's showing us from 2001 through 2009 what is being planted in the province, and it is pine, and quite a bit of spruce, but really it's pine that's being planted. So let's take a look at pine. So I'm going to cover off some of the work that Suzanne has done, and these are the sort of the study objectives they set out to look at with the study that I'm going to show you, and I'm really going to focus on these first two. So what is the condition of post-free growing lodgepole pine? And if there's damage, what is causing that damage? And do these declared stands continue to meet free growing standards past the juvenile stage? And then all these other also interesting and important questions. So trees with serious damage by Beck unit. And so we have the percentage of trees on the y-axis, and we have these different colored bars to show us the percentage of pine that's been damaged. So at the lowest 36%, at the highest almost 70%. And then the natural ingress, which is the blue bars. So trees that are just naturals popping up in the stand. Across all of these BEC units, we actually do see fairly high percentages of damage in the pine, and that damage is a lot lower in these naturally regenerated species. So who done it? I'm always interested in who done it. And so we can see across the different BEC zones, sort of who is responsible. Stem rust, stem diseases are really a big driver. And for those who really like the hard data, you can see that on the left by percentages, right? So Western gall rust is a really large one. Now, damage and incidents, you know, what the impacts of that damage are is a serious question. But there is quite a lot of damage to these sites. In the subboreal pine spruce zone, over 2,500 stems per hectare, trees per hectare are being damaged in some way, right? And so we maybe want to reevaluate our love affair with lodgepole pine. This is an interesting figure because what we're seeing in the kind of orangey bars is well-spaced, percentage of trees that are well-spaced, and percentage of trees that are free-growing within these different BEC zones. And this is at around 5 years post-declaration that these sites are being evaluated. So time passes, and what ultimately ends up happening? Well, there's a high percentage of trees that are no longer free growing across these different BEC units, or a very high risk that they will not be free growing. So any stand that was within 100 stems per hectare of the free growing stocking standards is in blue here. And so from a point of view of planting lodgepole pine, seeing all the damage that occurs and seeing what happens after free growing, this is problematic. And if this isn't being accounted for correctly, then we're going to be in for some nasty surprises. You know, and lots of people have done work in this area around the province and are sort of warning folks this might be something we need to really pay attention to. And these are a number of the papers that relate to this work. I'm also going to touch a little bit on one of Suzanne's studies called the Mother Tree Project. And so what this is kind of a climate gradient by harvesting technique by a number of different genotypes, replicated across the landscape with 3 replicates per study. So there's 9 climatic regions, from quite cool to quite warm, from quite very dry to quite wet, and with different aridity, so summer heat moisture ratios. Within these harvesting, we have 100% removal, 60 or 100% retention, sorry, 60%, 30, 10, and 0. So 0 being a clear cut. And then these 12 planted genotypes. And we can kind of look at these drier provenances through wetter provenances. And then these other species, Western larch, ponderosa pine, lodgepole pine, Douglas fir wild, and Douglas fir select. And so these are what these 5 treatments end up looking like at a single stand. So we have this 60% retention with thinning, and we have this 30% patch retention with the seed tree and clear cut. And you know, this is data that's just now in review, and so early days, but not surprisingly, really, is the richness of functional groups is lowest in the clear cut and highest in the control, with the retention patches or the retention treatments being somewhere in between. And you can see from this that certain functional groups there seem to be more affected than others through these different treatment systems. And then taking the example of redfish, which is a quite a mesic site and quite a productive site, this is what the natural regeneration is looking like years after harvest, right? So ingress since logging. And so we can look at this and go, wow, in the 60% retention, there's quite a bit of Douglas fir. We know Douglas fir doesn't love the shade, but yet here it is anyway. And we're seeing western red cedar, western hemlock, grand fir, small amounts of paper birch, etc. And so this pattern is very much the same in other sites. And the more xeric the site, the more important the retention. This is a large review, quite a lengthy review, done by a number of folks with a California focus, but with reforestation in dry western forests in mind. And I think there's things we can learn here. It's a long paper, so I just basically have some takeaways. There's also challenges. There is a focus on American forests and the challenges of federal lands and the ways they're managed that we don't necessarily have to deal with. But these are some of the takeaways that resonate for me, that it really is time to move away from pines and lines, and there's a number of reasons for that. Creating more spatially heterogeneous planting patterns can increase resilience of these young stands to fire and be more adaptive to moisture deficits. Certainly in California, they experience almost annual fairly severe drought, and then when they actually get a drought overlaid on that, things get really dry. But a lot of areas that we're looking at reforestation in BC, we see increasing drought effects or changing disturbance regimes, right? Zonation and prioritization. This to me is really key. So say you have a wildfire, like the King Fire, you break it up into zones where areas adjacent to green trees is where you expect natural recruitment, you know, especially, again, going back to your Silvix 101, what are the species, what is the dispersal distance, you know, what do I think my soils and moisture regime, am I likely to get regeneration? Zone 2 is further out where dispersal is going to be constrained and that natural generation will be very sparse or zero. And then 3 might be a zone where it could be like 2, where you don't expect there to be regeneration, but it's a zone that you may determine is too costly to plant for reasons of remoteness, safety, or topography, or trees established in an area, say topographically, it's a challenging site, maybe trees established during a climate pluvial, in which case, you know, during a period of wetness. And so they were able to make a living on thin to non-existent soils. And are they going to be able to do that in the future? You know, do we let those rocky outcrops, those concave surfaces be taken over by other species, shrubs, grasses, forbs, and herbs, which have functions to play in forests? And then again, this idea of variability again. So within zone 2, that area, so zone 1, you're going to leave alone because you suspect you're going to get natural recruitment. Zone 3, you're going to leave alone because it's too hard to get to and you don't think that recruitment, whatever you plant, is going to be successful. You're going to put your eggs in zone 2 and focus there. And this is a really good way to think about it because there's always going to be too much area to treat or to reforest than we could possibly do because we're dealing with such large areas in BC and Western North America generally. So within this zone 2, foster these variable spatial patterns, right? Where tree density and spacing is aligned with water availability, maybe topographic influences, the way we might expect fire to behave in the system over time. And so as I wrap up, you know, I think this is the time. I think we're past the time, but I don't think it's too late to change our perspectives and actions so we don't continue to miss the forest for the trees. So some take-home messages is vulnerability is going to be, it is the new normal. We are facing more vulnerable conditions all the time with climate change, hotter temperatures, hotter droughts, more moisture stress, etc. And so, you know, I think some of the partial cutting systems work, and I only showed you the mother tree. We have a vast network of partial cutting trials in this province. It shows us that maybe judicious use of clear cuts will be important because they're just a harsh area to try to regrow trees in. You know, avoiding off-site plantings, especially in lodgepole pine. If lodgepole pine makes up a very small proportion of the original stand, then it should make up a very small proportion of the planted stand after the fact. Embracing complexity. And I think embracing complexity not means only planting species mixes, but at different densities, in different patterns, reevaluating the role of broadleaves in many of our forests, and really turning to the science that is being done and has been done about what role these other non-timber species play in biodiversity and health overall. Overstory retention for successful regeneration. This is really crucial on harsh sites, which goes back to that judicious use of clear cuts, right? Under this hotter, drier world, is regeneration going to succeed on these harsh sites? Maybe some species will, but maybe other species we want to see back on those sites will not. And that reforestation and the IDF report really is looking at that, right? Overstory retention is going to help maintain some biodiversity in the system. Wildlife value conserves carbon storage capacity, which is increasingly important. You know, we don't only live in a timber world. Carbon is important. Mitigating climate is important. The social perspectives, the social, the way the society views our practices, views forestry practices is important. Always has been, sort of ebbs and flows. It's only becoming more important. And then from some of Suzanne's work specifically, and that is going to be published in a while here, is overstory retention seems to assist in the survivorship of the migrated genotype, which, you know, is an important piece of this puzzle as well. Long-term studies really matter, and we have them in this province. I didn't show you data from the provincial long-term silviculture trials. They're distributed all over this province in different ecosystems, and almost all of them are partial cutting systems. And the Mother Tree Project is another example of that. These, in our provincial research network, are our crown jewels, and we need to be preserving them into the future because they can answer questions we don't even have yet. Empirical research helps to educate, calibrate, validate, and motivate people. Education is bolded here because I really feel like extension is something that has fallen off the table. And it's that ebb and flow again of the way we do our work, the way we do our research, and how we share those results. And extension is a really critical piece of the puzzle, especially as new generations of foresters come online with limited experience. They're going to need to understand what the science has to say. A lot of the science has been done. You know, as a researcher, I'm always going to say there's pressing and important research questions, and there are, but the science has been done, and there is an urgent need for it to be implemented, not only implemented here and there, but implemented at scale. I don't think we have the choice any longer not to implement sort of some of the core things we know about forest health, forest succession, forest success, not to be doing it at scale. And then the barriers, quite simply, to implementation must be cleared. And those are probably largely cultural, legislative, and the fact, you know, that certain values will trump other values within the forestry world. So that's it for my talk, our talk. It was a very high level view of sort of the health of young stands, and some of the directions we think we should be looking at, and some of the things we think we should be talking about and paying attention to. I look forward to joining you for the discussion on the 24th. Good night.